Welcome to this web lecture about pointing devices. Before we get to the devices themselves, let's first look at the tasks they are used for. First of all, they are used to select items. You point at an item and then click to select it. For instance, in menu selection, to identify a file in a directory, right, or marking a part in a design. They are used to position, to point at a very specific point, maybe in the two-dimensional space of our screen, but it can also be used with some effort in higher dimensional spaces. There is a task of orienting. When we're creating a 3D drawing, we may want to change the orientation of what is displayed. Right? And it takes a bit of effort again to learn how to do that, but if you play with programs like Google SketchUp, you get to learn how to use the mouse to do orientation. Sometimes we need to draw a path. It can be freehand drawing, it can also be somewhat restricted, but we use a pointing device, right, to not only point at one point, but to draw a curve. Sometimes we use a pointing device to quantify. For instance, to use a slider to select a specific value from a large range. We can also use a pointing device to enter text, for instance, by pointing at elements on a virtual keyboard. The devices themselves, right, can be direct control or indirect control. A light pen, for instance, is direct control. You point at a certain position on the screen. It can be used to select. And you can then click a button to activate, right, some function at the position the cursor is resting on. There are a few problems with this and also other direct control pointing devices, namely that when you are pointing on the screen, even just with a pen, you are obscuring part of the screen. And in fact, when you point at an object, you are obscuring part of that specific object, and so you can't really see what it is you're pointing at. The other problem is that there is a lot of movement. You have to move your hands from the keyboard to pick up the pen, and then with the pen to move to the screen. So there's quite a bit of overhead in movement. What is easier to use is a touchscreen. We have touchscreens now on our phones and tablets, and sometimes on laptops, computers. It's direct control by touching the screen, mostly with your finger. Touchscreens use a different strategy for data entry than a keyboard. When you touch the surface, for instance on a virtual keyboard, the letter is not yet entered into the text. It is, and you can still correct, right? Because it's hard to point exactly at the right location, especially on a virtual keyboard on a small device like a phone. So you point and maybe you hit the wrong letter, but you can still move your finger. And when you lift off, the letter is entered into the text. On a regular keyboard, the letter goes into the text when you press down. And you can have an auto-repeat function. If you keep it pressed down, the same letter will be repeated. That is not possible on the touchscreen because of the lift-off strategy. The touchscreens are a complex device because they're fabricated together with the display surface. Right? So these screens are actually relatively expensive to build. Indirect pointing is best known from the use of the mouse. A good mouse design gives you a comfortable position of the hand. Your fingers will automatically rest on the buttons to be pressed. And even long motions with a mouse can be easy and rapid, and even precise pointing is possible. but it's all indirect. Right? You're not looking at the mouse, you're looking at where the pointer goes on the screen. An alternative to the mouse is the trackball. Traditionally, a mouse used to work with a ball underneath. The trackball has just moved this ball to the upper side and is controlled with your thumb. But essentially, the functionality is then the same. Other indirect pointing devices, joystick, graphics, tablets, they're like the touchscreen, but the touch part is separate. And sometimes also larger and often used with a pen. There are also touch pads. Right? It's like a graphics tablet, but you just use it with your fingers. All these devices have pros and cons and are better for some applications and worse for others. So we have to consider human factor variables to decide which device is best for the application we have in mind. For instance, the speed of motion. Traveling large distances is easy with our hand. It's reasonably well doable with a mouse. It's harder with a trackball. The control with the thumb, for instance, is somewhat harder. We need to consider accuracy of the positioning, where exactly we end up and how often we miss. The learning time to use the device. A touchscreen is much easier than a mouse. Other variables to consider, of course, are cost, durability, the space and the weight. Right? Using a mouse when you're on an airplane is really hard. Right? A trackball is much easier to use because the device itself doesn't move. You only roll the ball. Some devices can easily be used both left and right-handed, but other devices can't. Like a trackball has the ball on one specific side. We have to consider the likelihood that people will get repetitive strain injury after extended use. Now, often people say that the use of the mouse is causing RSI, yet when people are using the mouse with their right hand, they are more likely to develop RSI in their left arm. I don't know why that is, but it's not really the actual use of the mouse that is causing it. We have to consider compatibility with other systems than the computer systems where people also have to point. Some results from research that was done, experiments to find out what is better. Right? Direct pointing, for instance, is faster than using a mouse, but less accurate. And especially less accurate if the screen is relatively small. Graphic tablets are appealing when users can use it for an extended period of time. When you're creating a drawing and you stay on the tablet and you draw all the time, that's efficient. But if you have to switch back and forth between keyboard and the tablet, that's not so efficient. The mouse is faster than using a joystick. And if you have a mix of typing and pointing, that's where the cursor keys to move the cursor on the screen become useful, right, and faster and better than using a mouse. The muscular strain, right, is also lower for the cursor keys than for using the mouse to point. Now, how hard is it really? Fitts' law can be used to compute the difficulty of pointing at a specific point on the screen. It's a formula that uses several different aspects. First of all, there is the index of difficulty. And it's a function that increases with the dimension you have to travel, and it decreases with the size of the target you need to hit. It's like scoring a goal in football. The further you are from the goal, the harder it is to score. The larger the size of the goal, the easier it is to score. The time it takes to point at a certain point is a constant that depends on the device, right? And another constant depending on the device times the index of difficulty. So it's not only these distances and sizes that matter, but some aspects depend on the device. For instance, it can be that you need 300 milliseconds to start the motion on the device, and maybe another constant that says how hard it is per centimeter you have to move. So you can simply calculate. As the example on the screen, you have to move 14 centimeters to hit a target of 2 centimeters. You can simply compute with this formula that it will take 9/10 of a second to hit the target. There are some variants on this formula, especially for high precision pointing. Now, the difficulty of hitting a target can easily be seen through a simple experiment where users are asked to move back and forth between 2 points on the screen. What we see in this example image is that the precision and the randomness vary with age. When we ask a 4-year-old to do this, we see that the mouse movement and the pointing is moving all over the place. Just 1 year onwards, it gets already a lot better, and young adults can do it quite precisely. So it's not just old people that have trouble controlling a mouse precisely. You don't need to suffer from Parkinson's disease. Right? Young people still have to learn to move their hand exactly where they want it to go. There are many other devices. We're not going to discuss all these different ways in which we can point at objects. Right? You can pause the web lecture if you want to read all of them. There's so many options. Right? We've just covered the most common ones in this web lecture. Here are some illustrations taken from the Schneiderman book that show you first an image where someone is using 2 joystick-like devices. There is a touch pen that you can use to take notes and record audio at the same time. And then later, when you point at a word in your notes, it can play back through your computer what was recorded at that time. We see on the bottom left the use of a graphics tablet, and on the bottom right how people can collaborate by using large multi-touch screens, right, and horizontal surfaces where you can play either games or perform some collaborative mindstorming. The possibilities are endless. Unfortunately, all these novel and nice-looking devices come at a significant cost. Thank you for participating.